So we are streaming live, Pratyush. I'll just make you the host.
Yeah, sure. I have done it. Good afternoon, everyone.
Good afternoon, sir.
Good afternoon, guys. So we'll start with the class. Good afternoon, Sanjay. So we'll go through the formulas and then we'll directly start with the problems. So these are the few basic formulas. The differentiation of x to the power n is n x to the power n minus 1. E to the power x is e to the power x. A to the power x is a to the power x log a. Then log x differentiation is 1 by x. Log base a x differentiation is 1 by x. Log a base e. Sin x differentiation is cos x. Cos x is minus sin x. Tan x is sec square x. Cot x is. No, we are not reading maths. We'll be solving in another 4-5 minutes. I'm just giving you a glance of formulas because this will be used further. So cot x is minus cos x square x, sec x is sec x, and tan x, cos x is and all those stuff. Okay. Now, if you have the expressions like a square minus x square, so x can be substituted as either a sine theta or a cos theta. Similarly, if you have a square plus x square, so you can substitute a tan theta or a cot theta. X square minus a square, a sec theta, a cosec theta. And here in this case, it will be a cos theta and a cos 2 theta. So this will help you to solve the problems. Differentiation of the composite function. That is the chain rule. So implicit function d phi by dy equal to dy by dx. Sorry, into dy by dx. Try to solve question number 1, everyone. Happy? Shivam? Everyone, please try to solve question number 1. So what is the answer for the first one? See, y equal to tan inverse root under 1 plus cos x, 1 minus cos x. So this can be written as tan inverse 1 plus cos x can be written as twice cos square x by 2 twice sin square x by 2, correct? Which is nothing but tan inverse cot x by 2. So this is equal to tan inverse cot x by 2. Now cot x and tan inverse x we can't cancel, so we'll convert this. So it is tan inverse cot of pi by 2 minus x by 2, correct? So this will change to cot will change to tan. So this will become tan of x by 2 minus pi by 2 minus x by 2. Tan and tan get cancelled. So what is y equal to? Y equal to pi by 2 minus x by 2. So what is dy by dx? So for constant term, differentiation is 0. And for this second term, the differentiation is minus 1 by 2. So what is the answer for this problem? Minus 1 by 2. So answer is option A, minus 1 by 2. Okay, guys. Try to solve the second problem, everyone. Try to solve question number 2. And give me the answer in the chat box. So for question number 2, I will just erase question number 1. So f of x, what will be f of x for this? X square minus 5x plus 6. What is the differentiation of this? 2x minus 5, correct?
Now, so before solving this, first of all, we should find out about f of x. What is f of x? X square minus 5x plus 6. X square minus 5x plus 6. If I split this, it will be x minus 2, x minus 3. So from here, we are getting it as x is greater than 2, x is greater than or equal to 3, correct? So this is positive. This equation, x minus 2 and x minus 3 is positive when x is greater than 2 and x is greater than 3. This is also positive now. If x is greater than 2 or x is greater than 3 means what? X should be, what we'll get from here? If I solve this inequality, what I'll get? X should be greater than equal to 3, correct? So this is positive when x is greater than equal to 3. Or x is less than equal to 2. This is positive in two cases. Either x is greater than equal to 3 or x is less than equal to 2. It is negative. This equation is negative, in which case this equation is negative if x is in between 2 and 3, correct? So this equation is positive in this case. And the same equation is negative in this case, correct? The second case. See, for all the questions, it is like 2x minus 5 only, correct? 5 minus 2x or 2x minus 5. Now we have to find out which solution fits here. Between 2 and 3. So between 2 and 3, x is negative, correct? So if x is negative means f dash of x should be less than 0, correct? If it is less than 0, then 2x minus 5 should be less than 0, correct? Means this term should be negative. If it is negative, it should be like 5 minus 2x. I hope you are getting it. So option A is ruled out. What about option C? If x is greater than 2, if x is greater than 2, we'll not get anything, correct? If x is greater than 2, we can't say it is positive or negative. So we can't say anything about C. X should be greater than equal to 3, then we can say it is positive. What about D part? X is less than 3. X is less than 3, still we can't say anything about this. Because x is less than 3 and more than 2, in that case only we can say it is negative. So even this can't be, so answer is this. And this is, we can prove also. Between 2 and 3, between 2 and 3 means this case you can take. Between 2 and 3, this should be negative. If this is negative means we are taking minus 5 plus 2x. Instead of taking 2x minus 5, we'll get the answer as minus 5 Sorry. What I'm doing. We'll get it as, just reverse the sign. So we'll get it as minus 2x plus 5. What is the negative of this? Negative of this equation is minus 2x plus 5. So minus 2x plus 5 is option B. So answer is option B. Any doubt, anyone? Sunil, Komal, Sanjay, Avinash, any doubt? Ritik, any doubt? Saluza, Sujan, any doubt? Why B? Okay. I'll again explain this entire thing. See, first of all, we have to find x square minus 5x plus 6. We'll factorize this. We'll get it as x minus 2, x minus 3, correct? Now, x minus 2, x minus 3. Now, why all this is happening? Because mod is given. Why we are taking plus, negative, or positive and all? Because mod is given. Now, if I take anything out of the mod, if I take this equation out of the mod, it will be either minus x square minus 5x plus 6, or it will be positive x square minus 5x plus 6. So we have to find in which case it will be negative and which case it will be positive. So x minus 2, x minus 3. In which case it is negative? For this entire equation to be positive, isn't it? This has to be greater than or equal to 3, correct? Then only this will be positive. We'll get the positive equation. This is the positive equation. And this is the negative equation. To get it positive equation, the x value should be greater than 3. Or to get positive equation, both the values should be less than 2. If both the values are less than 2, again the equation will be positive, correct? I hope you're getting it. Now, in which case it will be negative? Where will this equation becomes negative? Where will this equation becomes negative? If x is less than 2, or if x is greater than 2 but less than 3. Greater than 2 but less than 3. In this condition, in this particular condition, this equation will always be negative. So these are the 3 conditions, correct? Now we have to find the solution. Now we know what is the differentiation of x square minus 5x plus 6. What is the differentiation of this? F dash of x equal to 2x minus 5. So we have to find 2x minus 5. So we'll check 2x minus 5. Between 2 and 3, this is positive or negative? This is positive equation and negative will be minus of 2x minus 5, which is nothing but 5 minus 2x. So this is the positive equation and this is negative equation. So in which case I will get positive and which case I will get negative. So option A will check. In option A, am I getting positive or negative? Between 2 and 3, this is negative, but this equation is positive. So this can't be the answer. Are you getting it, guys? Komal? So option A is not possible because between 2 and 3, this particular equation should be negative, but here it is positive. This is about the positive equation and negative equation. So option A is ruled out. What about option C? Now, since I have already told that option B is the answer, so we'll first check option C. Why C is not the answer? If x is greater than 2, what is happening if x is greater than 2? Can you say anything about x is greater than 2? X greater than 3 is positive. X less than 2 is positive. Between 2 and 3 is negative. But just greater than 2, we can't say anything, correct? We can't say anything about the equation. Just for greater than 2, we can't say anything about the equation. Now what we have? 5 minus, we have option D. Let's check option D. What happens if x is less than 3? X is less than 3. X is less than 3, but it should be greater than 2 also. Then only we can say it is negative. So this is also incomplete. So only one option is left out. Now that option, if you check between 2 and 3, this is negative equation. So I should get this part correct. Between 2 and 3, I should get this equation. So this is happening only in the option B. Anyone else has any doubt? Guys, you have any doubt? Anyone? So we'll try to solve question number 3 and question number 4. Question number 3. So question number 3. Very good, guys. Your answers are correct. Sanjay, Komal, and Ritik has given the correct answer. Good afternoon, Jayanta, Acharya, Ranjan. So we'll see here. Tan inverse x. Question number 3. I'll try to solve here. So y equal to tan inverse. What is log a by b? Log a by b is log e minus log of x squared divided by log of e minus plus log of x squared. Okay. Plus tan inverse. This is like 3 plus 2 log of x. This is 1 minus 3 into 2 log of x. Already we know that tan inverse a tan inverse a plus b 1 minus ab. What is this equal to? A plus b, correct? So Similarly, if plus is there, we get plus. If minus is there, we'll get minus. So directly we can write it down here. Log e value is 1. This is like 2 log x. 2 log x. So how much we are getting it here? 1 minus 2 log x plus how much we are getting it here? 3 plus 2 log x. Minus log x plus log x got cancelled, so y equal to 4. If y equal to 4, what is y dash equal to? 0. So what is the differentiation of constant? It is 0. So what is the answer for this question? Option C. Okay, Sanjay and Ritik.
Sir, I didn't understood second step. 1 minus 2 log x, that one.
Got it from here. This is the formula for tan inverse. Now, if you see, this is 1 minus 2 log x, correct? And in the new denominator, we have 1 plus 2 log x. So isn't it comes on this formula? That is tan inverse a minus b, 1 minus ab equal to a minus b. So directly a minus b is out.
Tan inverse a plus b.
Huh?
Tan inverse a plus b upon 1 minus ab.
Yeah, sorry. So this is like tan inverse a minus tan inverse b. Tan inverse 1, tan inverse this, tan inverse this, tan inverse this. So it is tan inverse 1 minus tan inverse. So, sorry, my mistake, blunder mistake. I was so happy that I was getting answers easily. So it is like tan inverse A, tan inverse B. Okay. So here we get it as tan inverse 1 minus, sorry, plus tan inverse 3. Both are the constant terms. So still the answer will be 0. Are you getting it, guys? Any doubt, anyone?
No, sir.
Try to solve question number 4, please. Yes, Ritik, your answer is correct. Komal, your answer is correct. So let's try to solve question number 14. So it is given. So what is the differentiation of y dash? It is f dash of f of how many f are there? 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 4. F of x. Then we have to differentiate this. So it is f dash of 0, correct? Sorry, x. Next we have f dash of x. Then finally we have f dash of 0. Correct. So how many functions are there? 1, 2, 3, 4. Now what is f of 0? F of 0 is 0. So if f of 0 is 0, so this is 0. If this is 0, this entire term is 0. This entire term is 0, correct? So this entire term will come as 0. So finally it will come as f of 0, correct? F dash of 0. How much will this come as? Again, it will come as f dash of 0, f dash of 0, and it is also f dash of 0. What is f dash of 0? 2, 2, 2, 2. So what is the answer? 16. So answer of this question is option C, that is 16. Ritik and Komal, your answer is correct. Anyone has got any doubt? Guys, do you have any doubt? Try to solve the next one. Question number 5 and 6. Try to solve question number 5 and 6. People, those who are watching on YouTube, can also answer in that live chat. So let's do. this problem. So what is dy by dx? A into n minus n plus 1 x to the power n minus bn x to the power minus n minus 1. What is d2y by dx square? So again, it is a into n plus 1 into n x to the power n minus 1. And here we'll get it as minus common. So it will become plus b into n plus 1 x to the power. Please don't talk. X to the power minus n minus 2. If you have any doubt, please ask, but please don't talk on mic. So now what we are getting it here, what is common? n into n plus 1 is common, correct? So what is there inside? A into x to the power n minus 1 plus b into x to the power minus n minus 2. Now how much we have to multiply here? X square. So I'll multiply x square both the sides. So if you multiply x square both the sides, if you multiply x square both the sides, what you will get? So x square d2y by dx square. If I multiply x square here, it is n plus 1 x square. So what it will become? A x to the power n plus 1. And what it will become? B x to the power minus n. So this entire value is nothing but n into n plus 1. And this entire value is y, correct? So it is n into n plus 1 into y. Option B is correct. So Ritik, your answer is correct. Anyone from the class who has got the answer? Except Ritik. Any doubt, anyone? Guys, any doubt? Avinash, Sanjay, Santosh, Sunil, any doubt? Sunil, any doubt?
No, sir.
Komal, any doubt? Shaluja, any doubt? Okay, so try to solve the next one. Question number 6, please. Try to solve question number 6. So dy by dx equal to 1 becomes 0, x becomes 1 plus x plus 3x square by 3 factorial, correct? Plus 4x cubed by 4 factorial and so on. The last one will become n into x to the power n minus 1 by n factorial. So what is dy by dx? 1 plus x plus, this is x square by 2 factorial plus x cubed by 3 factorial plus x to the power n minus 1 by n minus 1 factorial. So that means from here to here, isn't it? It is the same thing. The second last will be the same thing, correct? So this portion can be replaced by y minus x to the power n by n factorial, correct? This entire portion can be replaced by dy by dx equal to y minus x to the power n by n factorial. There is just one term before the last term, correct? So this entire portion, I have replaced by y minus x to the power n minus n factorial. So answer is option C is correct. So Saluza, answer is C. You might have missed somewhere. Any doubt, anyone? Anyone from the class has got any doubt? Santosh and Gautam, any doubt? Which one you want me to explain? So Jain wants to explain. Okay. So let's see. See dy by dx. dy is this. So dy by dx. First term differentiation is 0. Second term differentiation will be 1. X square differentiation is 2x by 2. 2x by 2 is x. This will become 3x square by 3 factorial. That is x square by 2 factorial. Last term will become n into x to the power n minus 1 by n factorial, correct? Now if you solve this and this get cancelled. N and n factorial get cancelled. So in denominator we got this much. Okay. Now this entire portion, if you check this portion, this part and this part is equal, correct? These two parts are equal. So I have replaced, instead of this, I have replaced dy by dx. So dy by dx equal to y minus x to the power n minus n by n factorial. Okay. Try to solve this question number 7. Try to solve question number 7, everyone. What is dy by dx? This is a cos x minus b sin x. So square of this plus y square. So y square plus dy by dx whole square can be written as y square is a sin x. So it is like a square sin square x plus b square cos square x plus 2ab sin x cos x. What else we are getting it here? Plus dy by dx whole square. So if I add dy by dx whole square, how much I'll get? A square cos square x plus b square sin square x minus 2ab sin x cos x. If we check, this 2 part is 0, correct? So this 2 part is equal to 0. Now this 2 part, if we take a square common, this is sin square plus cos square. Sin square plus cos square is 1. So it is a square. This 2 part, if I take b square common, sin square plus cos square is 1. So answer is b square. So it is a square plus b square. A square plus b square is option D. It is a constant term. Very good. Ritik, Santosh, Sanjay, and Avinash has given the correct answer. Very good, guys. What happened? Komal, Saluja, Santosh has given. Gautam. Anyone from the class has got any doubt? Anyone from the class has got any doubt? Try to solve question number 9 and question number 10. So what is dy by dx? N into x plus root under x square plus a square n minus 1 plus, sorry, not plus, into. Now x, what is the differentiation of x? X is 1 plus root differentiation is 1 by root x square plus a square. X square differentiation is 2x. Which is equal to n x plus root under x square plus a square n minus 1. 2 and 2 get cancelled. So it is again equal to root under x square plus a square plus x whole divided by root under x square plus a square. Yeah. Now, the first term and the second term, if you multiply, how much you will get? First term and the second term, if you multiply, what you get? You get it here. This entire portion is like x plus root under x square plus a square whole the power n divided by root x square plus a square, which is equal to n divided by root x square plus a square, and this entire portion we can write it as y. So dy by dx equal to so much. So answer is option A. Answer is option A. Any doubt, anyone? Anyone from the class has got any doubt? Try to solve the next one, question number 10. Jain, your answers are correct. Jayanta, your answers are correct. So we'll try to solve question number 10. So f dash of x equal to, what is the differentiation of root that is root 2 1 plus cos square x square, and then we have 1 differentiation is 0. Cos square differentiation is twice cos x square. Then we have sine x square. X square differentiation is 2x, correct? Now if so, this 2 and this 2 will get cancelled. So it is f dash of x equal to sine 2x square divided by 1 plus cos square x square. So what is f dash of root pi by 2? So this is sine. Root becomes, this becomes pi by 2. Sorry, x is remaining. So x will become root pi by 2. And denominator will become 1 plus cos square x square. X square is pi by 4. Pi by 4. Cos pi by 4 is 1 by root 2. 1 by root 2 square is 1 by 4, correct? Sorry, cos square differentiation will come as minus also, correct? Minus sign. So this is root pi. Pi by 4. 1 by root 2. 1 by 4. 4 plus 1, 5. So this is 1 by 2 only. So this is 1 by 2. So how much we are getting it here? Minus is there. So minus root pi. This is 1. This is 1. This is 2 plus 1, 3. So it is 2 pi root 3 by 2. So minus pi by root pi by 6. Very good, guys. Your answers are correct. That is option B is correct. Komal and Avinash has given the correct answer. Anyone from the class has got any doubt? Question number 10. Anyone has got any doubt? On YouTube also, anyone has got any doubt? Without calculator, you should have found, then it's funny. Sanjay. Without calculator, if you find, then only it is hilarious, correct? Did you find without a calculator or using calculator, Sanjay? Then it's good. Try to solve question number 11. Try to solve question number 11 and 12, please.
Yes, Sanjay, your answer is correct. Ajay also, your answer is correct. Sanjay Dhaval, your answer is correct. Sanjay Baitha, your answer is not correct. Yeah, Sanjay, your answer is correct. So let's try to solve. So differentiation of cos inverse. What is the differentiation of cos inverse x? It is 1 by root under 1 minus x square, correct? So cos inverse x differentiation becomes
Sir, minus 1 upon root under 1 minus x square.
so here. This will become root under. So what is differentiation of this? This will become 1 minus cos, root cos will become cos, correct? Root under cos, its whole square will become cos. Now what is the differentiation of root cos? So what is the differentiation of root? This root cos twice. What is the differentiation of cos? Minus sin x. So minus of minus will become plus. Okay. So now further we have to just simplify this. So they have not given in the half angle, so we can't convert into the half angle. So what we can do, we can multiply numerator and denominator with
root under 1 minus cos x. So we'll multiply numerator with 1 plus cos x, denominator also with 1 plus cos x. So how much I'll get it here? Sin x, root under 1 plus cos x, twice. Now root under 1 minus cos x and 1 plus cos x is how much? 1 minus cos square x. 1 minus cos square x is 1 minus cos square x is sin square x. Sin square x root is sin x and root cos x. So sin x and sin x get cancelled. So this is further equal to 1 by 2 root. Now 1 by cos is sec x and plus 1. So it is half of this. So answer is option A, that is half of root under 1 plus sec x. Any doubt, anyone? Question number 12. Try to solve, everyone. Question number 12. Ajay, your answer is correct. Others also please try to solve question number 12. Log A
base b is written as log a by log b. So log a base b is written as log a by log b. So this here y will be written as log of tan x by log of sin x. So y dash, that is dy by dx. So we'll solve this problem on u by v form. Okay, so u by v form is like log sin x. Log tan x will become tan x. Tan x differentiation is sec x square x minus. Now it is log tan x sin x. Sin x will become cos x. Whole divided by log of sin x whole square. So we'll directly substitute pi by 4 value in this itself. Instead of solving, we'll directly substitute pi by 4. So that things will become a little bit easier. So pi by 4. So this is like log 1 by root 2. This is root 2 square is root 2 square. Tan pi by 4 is 1 minus, how much we'll get it here? Log 1. Now log 1 value is 0, correct? Sorry, tan pi by 4 is 1. So log 1 value is 0. So this entire term will become 0. So negative term is gone. What is remaining here? Log 1 by root 2 whole square. Log 1 by root 2 whole square. So what is there? So this entire term will cancel this entire term because it is the square terms. Root 2 square is 2. So now here we have log 1 by root 2. So log 1 by root 2 can be written as 2 to the power 1 by 2, correct? Minus, which is 2 divided by minus 1 by 2 log 2, which is 2 will go up minus 4 by log 2. Minus 4 by log 2, so the answer is option C. Any doubt, anyone? Anyone has got any doubt? Gautam, Ajay, any doubt? Sunil, Sujan, any doubt? Okay, try to solve question number 13 and question number 14, please.
So question number 13. Sine inverse Okay, so we'll directly try to solve. We will take u by v form. So sine inverse differentiation is, so this is 1 minus x square. Sine inverse differentiation, inverse differentiation is 1 by root under 1 minus x square minus sine inverse x. This differentiation is twice 1 minus x square. Minus of minus will become plus, will 2 whole divided by 1 minus x square. Here this and this will get cancelled, so it is like plus 1 sine inverse. 2 and 2 get cancelled, so it is x by root under 1 minus x square. 1 minus x square. So now what they want? They want, so this is dy by dx. So how much it is? 1 minus x square into dy by dx equal to 1 plus, and this entire value we can take it as y. So it is x into y. So answer is 1 plus xy. Option B is correct. So question number 13, answer is option B. Question number 13, answer is option B. Try to solve question number 14, please. If anyone has any doubt, please ask.
So what is the answer, guys? So how to solve such kind of problems? We'll first of all rationalize the internal part. So to rationalize, multiply numerator and denominator with 1 plus sin x plus root under 1 minus sin x, 1 plus sin x plus root under 1 minus sin x. Now, if you have a good practice of it, you can easily write it down. No need of writing this part. You can easily rationalize. So how much you will get it here? Cot inverse. So this is like a plus b whole square, correct? So a plus b whole square is 1 square, a square, so 1 plus sin x, 1 minus sin x. So a square plus b square is a square plus b square, so 1 plus sin x, 1 minus sin x. And then what we have? Root under twice root under 1 minus sin square x whole divided by, again in denominator it will be just like 1 plus sin x minus of 1 plus sin x. So how much we are getting it here? Cot inverse plus sin x minus sin x get cancelled. So it is like cot inverse 2 plus 2 root 1 minus sin square x is 1 minus sin square x is cos square x. Cos square x is cos x. So this is 1 plus 2 cos x whole divided by 2 sin x, which is further equal to cot inverse 1 plus cos x by sin x. Further, we can write it down. Cot inverse 1 plus cos x is 2 cos square x by 2. And this is 2 sin x by 2 cos x by 2. So how much we'll get it here? 2 and 2 get cancelled. This get cancelled. Cos by sin is cot. So we got it like y equal to x by 2. If y equal to x by 2, what is dy by dx? 1 by 2. Question number 14, answer is option A. Any doubt, anyone? Guys, do you have any doubt? Anyone from the class has got any doubt? Any doubt, anyone? Try to solve question number 15 and question number 16. Try to solve question number 15 and 16. So let's try to solve question number 15. So y equal to x to the power, we'll take it as u. So what is u? U is x to the power x. We'll take log both the sides. So if you take log both the side, log y equal to u log x and log u equal to x log x. So now we'll differentiate. If you differentiate this, what you will be getting? If you differentiate log y, it is 1 by y dash u. If I differentiate u, it is du by dx into log x plus u by x. Now other side we have log u, again differentiation of this will be 1 by u du by dx equal to x differentiation is gone and log x differentiation is 1 by x into x is 1. So what is du by dx? Du by dx is u into, that is x to the power x into log x plus 1. We'll substitute in this solution. So what is y dash equal to x to the power x whole into du by dx. Du by dx is x to the power x log x plus 1 plus u by x is x to the power x by x, we can write it as minus 1. So what is the answer here? Y. So outside the term is y, that is okay. So it is x to the power x minus 1 . So obviously this 2 can't be the answer. Now what is this part? This is log ex, which is also equal to log e plus log x, which is also equal to 1 plus log x, correct? So that is 1 plus log x. So answer is option C. So answer of this question is option C. Anyone has got any doubt? Guys, do you have any doubt? No one has given answer of question number 15. How so? How come? Why so? Anyone has got any doubt in question number 15? So this is log. Try to solve question number 16, please. So let's try question number 16. We'll first of all put x equal to cos theta. So here it is root under 1 minus cos theta 1 plus cos theta. So what is this formula? This formula is used for what? One minus cos theta can be written as twice sin square theta by sin square theta by 2 twice cos square theta by 2. So further, this is nothing but sin by cos is tan theta by 2. So this part we have got it as tan theta by 2. How we can write tan theta by 2 in cot? So it will be cot pi by 2 minus theta by 2. It will be cot pi by 2 minus theta by 2. So from here to here, we have solved. What we got? Sin square pi by 2 minus theta by 2. Okay. What is the differentiation of sine? Sin square, it is 2 sine pi by 2 minus theta by 2. Okay. Before that, what we can do? What is sine pi by 2 minus theta by 2? This is equal to cos theta by 2. So it is cos square theta by 2. What is cos square theta by 2? If I multiply 2 and divide by 2, so twice cos square theta by 2 is 1 plus cos 2 theta. So 2 theta will become theta whole divided by 2. So y equal to this much. So what is dy by dx? One differentiation is gone. It is minus sine theta by 2.
So sin theta by 2.
Wait. Not required this part. And this becomes how much? Cos theta is anyways x. Cos theta is anyway x. So if I differentiate this, what I'll get? 1 by 2. So answer is option B, 1 by 2. So anyone has got any doubt in today's session?
Sir, x. So 2 cos square theta by 2.
2 cos square theta by 2, what is that? That is 1 plus cos 2 theta formula. 1 plus cos theta. Okay. I hope you know this. Twice cos square theta by 2 is equal to 1 plus cos theta. Now cos theta already we have taken as x, so it is 1 plus x. 1 plus x dy by dx is x by 1 by 2. So answer is 1 by 2. Anyone from the class has got any doubt? No doubt, guys. Okay, so thank you, everyone. You guys can leave for the break. Thank you, guys. Please be back by 6:45 in another 10 minutes.
Okay, good evening. We'll start off our physics session. Today our session is on basically things related to sound, you say, or waves, you say, oscillations, you say. Important part of physics. Starting with simple harmonic motions. First one is what you're supposed to know, what's a periodic motion. We'll just try to revise this, all things you have read it already, so just fast revision. In the terms, any motion which repeats itself after a regular interval of time, that is known as periodic motions. That is motions of planets around the sun, motion of pendulum of wall clock. Okay, what is oscillatory motion? The motion of body is said to be oscillatory. It means basically if it is going and coming in same position again and again, like this is a pendulum, a mass, it goes here and then again comes, it goes like this and then again it comes like that. So again it goes like this further on this side and then again comes back to this position. So this is what this is, oscillatory type of motion. The simplest harmonic motion, a simple harmonic motion is the simplest form of vibratory or oscillatory motion. So basically both the conditions will be satisfied over there. It's an oscillatory motion. Okay, this is, so simple harmonic motion is basically the simplest form of oscillatory motion. What is an oscillatory motion? Which is it's like a to and fro motion at a fixed time interval. Okay, basic terms related to your SHM, mean position, where the particle is at zero, the restoring force, it will be at zero position, like say when I'm talking about where x is equal to 0, and where that what is extreme position, when x will be equal to a, that is an amplitude. When x becomes equal to a, that becomes amplitude. When it becomes equal to amplitude, that time it have what maximum displacement. That's what we try to represent when we are talking about in terms of, when you're trying to draw the graph, like say if I'm trying to have a sinusoidal graph. Sinusoidal graph basically is related to sine and cosine. So if I'm trying to draw the graph, I'll have some highest points. So this highest point will be always constant, and this highest point is what? That's amplitude. So maximum displacement, what is possible is amplitude. So that is what we say at extreme position. Restoring force, any particle which goes under motion will try to come back to its again to the same position. So that is what is your restoring force. Amplitude, the maximum positive or negative value of displacement, either it goes to the positive direction of y or it comes to the negative direction of y. So that's the maximum displacement which is possible for a particular time period. Now what is a time period? If I'm trying to define number of oscillation per second. Okay, so that is what this formula already known by all of you. T is equal to 2 pi omega 1 by n. Okay, where W is an angular frequency and n is the frequency. We write it as the formula of is equal to 2 pi angular frequency. Okay, and I know that frequency and time period are related to each other as a reciprocal. You write it as n, you write it as f, anything is fine. Okay, now so this is what is basically one oscillation or one vibration. So this is what will be total one oscillation when it have what? One crest will be there and one trough will be there. That is one oscillation. Okay, so and that's how we try to count it. And when I'm talking about wavelength, distance between one two successive crest or two successive trough, that is what is known as wavelength. Wavelength, the distance which is covered by the sinusoidal graph. In terms of that, so frequency, again we have phase. Phase is what? Phase is basically phase of a vibrating particle at any instant is a state of vibrating particle regarding its displacement and direction of vibration. So where in which direction it is vibrating and how much, it is decided by phase. When you basically to study a comparative parameter, like if you're trying to compare a motion of A and B, so you find out, yeah, this much is the phase difference. This is how they'll be vibrating in with respect to each other. Okay, obviously the phase at time t0 is known as initial phase or epoch. Okay, this you should know what is epoch. So when at time z when time is 0, that is what is known as initial phase, or that is what is known as epoch. Okay, these are the few terms which is there in terms of when we talk about angular SHM or linear SHM. What you're supposed to know is linear SHM. In linear SHM also, what majority what you have to know is this. This is what is displacement. In general, if I want to write displacement, I write x is equal to a sine omega t plus phi. Now, if this is displacement, if I'm trying to differentiate displacement, say if I'm trying to differentiate displacement, I'll get dx by dt. I have to differentiate this. I'll get it as what? I'll get it as differentiation of this will be what? A cos omega t plus phi. Then phi is a constant. So basically I'll get differentiation of omega t, that is omega, which will give you what? A omega cos omega t plus phi. Now, if I have this thing, if I want to change this in the write it in the form of sine, what I'll write? I can write cos as what? Root under 1 minus sine square omega t plus phi. So I can write from here what? That this is a omega. Inside that, what I can write? I can write 1 minus sine square omega t. From here, if I want to write sine omega t plus phi will be x upon a. So square will be what? X upon a whole square. So basically I get this. So final formula I'll get it in this fashion. Correct. This is what I'll get. Now, if I have to find out V maximum, so for finding out V maximum, what is the thing that if this term becomes equal to, if this x square becomes 0, then it will become what? A square under root will become a. So V for V max, what I have to do, that x equal to be 0, x is equal to 0, 0 in mean position. So V max value will be what? It will become omega a. And if I'm trying to find out V minimum, so basically if x becomes, so it will become 0. When it will become 0, when x is equal to a. So you substitute x is equal to a here. So a square minus a square is 0. So total, and this is only possible at extreme position. So this is how we find out the velocity related to your SHM executing particle. Now, if I have this thing, velocity thing, so now I actually, what velocity I got? Now velocity is equal to what? Omega a square minus x square. So if I'm differentiating this, differentiation of velocity gives me acceleration. So if I differentiate this, this will give me what? This will basically give me minus omega square x, right? Negative omega square x if I'm trying to accelerate it. So because differentiation of this 1 by 2 a square minus x square, a square will be constant. I have to differentiate this. 1 by 2 will get cancelled because of this 2x. Okay. Again, in this case also, I can find out a max and a minimum value, substituting the values for x. X is equal to a and x equal to 0 will give you a maximum, a minimum value. You're supposed to know these three equations here. The further equation for you, you're supposed to know is kinetic energy, potential energy, and total energy. So kinetic energy is basically half mv square, which is given as half m omega square. Because v square value I substituted here, so v square is omega square a square cos square t plus phi. So when you substitute this, now you can see that when if I'm trying to see a square, if I'm trying to convert it into the form of this related to xy, I can write it in this fashion. Okay. Total energy, see here, if I'm writing, say, if I have kinetic energy is equal to what? Half m omega square a square cos square omega t plus phi. This is what I have. So now you know that if I want, because I know the value for sine, that x is equal to this much. So if I want to write it in the terms of sine, what I'll write? I'll write it as, okay, I'll write it as what? Omega square a square is basically, if I have a square, so a square value with this side, so I'll just write it as a square cos square omega t. I can write it as 1 minus sine square omega t plus phi. So basically, if I write it, it will become half m square omega square a square. I'm multiplying a square here, so this will be 1 minus sine square omega t is what? This will be equal to x square. So if I write it, it will become what? Half m omega square a square 1 minus a, or you can multiply a square inside as well. That's all, that depends on you. But I have only what? I have sine square phi, sine square I need to multiply inside. So a will be multiplied inside then only. So this a will be, okay, this a will be not here. No? Okay, I'll write it as what I'll do is I'll first multiply this inside. So I have what? Half m omega square. Then I have what? A square minus a square sine square omega t plus phi. So this total term is equal to x square, right? This total term. So I can write half m omega square A square minus x square. This becomes your kinetic energy. In similar way, if I'm trying to write potential energy will become what? Half m omega square. Now a square sine square omega t phi is already in the terms of x. So I'll just substitute it here, this x square. Now if you see, you add both of this, so you'll get it, your total energy, you'll get it as half m omega square A square. Now mass of a body is constant, half is constant, omega square angular frequency is constant. Amplitude for a wave doesn't change unless and until it's a damped vibration. So we are considering it to be undamped vibrations. In undamped vibration, where it is not being disturbed by any external agent, so it is, so that's why it's equal to constant. So that's why we say that total energy of a body which is executing SHM is constant, and this is what is the values here. So this will be equal to what? Half m omega square A square minus x square, and then this is what? This will be half m omega square x square. So that's why they get cancelled, and I get it as half omega square. So this three. So what all you're supposed to know is basically you have to know this. For linear SHM, f is proportional to minus x. Minus x, this x is what? This is displacement, and this is what is known as force law as well in terms of SHM. This particular statement, f is proportional to minus x, is known as force law. So you'll just focus on the linear SHM part. So you have to know this. For linear SHM, you need to know displacement, you need to know velocity, acceleration, kinetic energy, potential energy, and total energy. Okay. So this is what are the values which you are supposed to know. Which ones? This is force law. Displacement you should know. Velocity you should know. Acceleration you should know. Kinetic energy, potential energy, and total energy. This is all you're supposed to know. This all is not hard. If you see, this all can be written here in this form. X is there, which is displacement. So once you know this, you can just differentiate them to find out the further values of velocity and acceleration. And when I'm talking about, so if I'm talking about velocity, I get it as what? I get it as omega A square minus x square. If I'm talking about acceleration, I get it as minus omega square x. So I'm talking about kinetic energy will be half m omega square A square minus x square. Then if I'm talking about potential energy will be half m omega square x square. When you add this two, that is total energy. Total energy is equal to half m omega square and A square. That's why we write that total energy is constant. So this is what is important on this page. Okay. So that's how you differentiate x, you get velocity. You differentiate velocity, you get acceleration. Kinetic energy, we have half mv square. So v formula we can use from here itself. Okay. So that's from here only we can write it. By differentiation also I shown you. V square will be always omega square A square minus x square. So I substituted it here. Potential energy is equal to half kx square. So x is this here. Okay. This is x. Total energy is addition of this. Okay. This is important, so you're supposed to know this. Okay. Next, you need to know the graph for this. So you can see that total energy that doesn't matter because it will stay constant, right? It's all the values are constant for this. Within the, you talk about with respect to displacement or with respect to time, total energy is not changing. It's constant because it's not dependent on it. They have all the constant values, have amplitude, doesn't have anything related to x or time. So it will change with respect to time or displacement. Yeah, when you are moving kinetic energy and potential energy in that. So yeah, this is what it is. So you can see that here we have the positions of kinetic energy maximum. Okay, kinetic energy maximum will be at which? Now we have kinetic energy maximum. So kinetic energy formula is what? Kinetic energy is equal to half m v square, so a square, omega square A square minus x square. So to make this maximum, I need to have this 0. So this is only possible at mean position. So I'll get the maximum value kx will be half omega square A square. So k max kinetic energy max is half m square A square. So this is what is this value, half m square omega square A square. Now when I'm talking about minimum value for this, minimum will be this, when this term is 0, that will be, so k minimum will be where? Ke will be minimum when x is equal to a. So that time it will be equal to 0. If talking potential energy formula is what? Potential energy is half m omega square x square. So to make P maximum, it will be equal to A. When x is equal to A, that time I write it as half omega square A square. So you can see that at this position, when I'm talking about U is maximum, at that position U will the potential energy will be minimum, and at potential where, so that's why every point the sum will be equal to total energy, because one will be maximum, so other will be minimum, so they'll counter attack each other's, and the sum of kinetic energy and potential energy will be same every time. Okay, so that's what is written. Total energy of the particle is same at all instant and at all time. That means with displacement and with time. Total energy depends on mass, amplitude, and frequency of vibration of the particle executing SHM. It depends on the mass, it depends on amplitude, A, frequency, angular frequency is there, omega. So only on that values it depends. Okay. Moving further, differential equation of SHM. In very adverse condition, you can get this question though. You have to just differentiate it. You would have studied differential equations. Okay, there are few formulas related to series combination of spring, where we have to just know the formula. So T is equal to 2 pi m by k effective. K effective in series is calculated as 1 by k effective equal to 1 by k1 plus 1 by k2 plus 1 by k3. Parallel combination, k effective is k1 plus k2 plus k3. Substitution, that's one. Time period of a simple pendulum is 2 pi L upon G. Okay, now what we have to come across is, now see, SHM is a part from where we expect questions directly. This and all, we have definitions few, and then from there we get numerical based questions. So now free, damped, forced oscillation and resonance we have to talk about. Now what is a free oscillation? The oscillation of a particle with fundamental frequency under the influence of a restoring force. There's no external force in that, only fundamental frequency will be there, nothing extra, nothing have been externally put in that, all that. So it will normally, so this kind of free oscillation, basically what they'll have every time same amplitude. The amplitude will not change. Okay, but when I'm talking about damped oscillation, so oscillation of body whose amplitude goes on decreasing with time are defined as damped oscillation. Simple definition, which is decreasing, amplitude is decreasing with respect to time. In this oscillation, the amplitude of oscillations decreases exponentially due to damping forces like frictional force, viscous force. What is frictional force? What is frictional force? Frictional force is basically an opposing force. Viscous force is also an opposing force, depending on if you're keeping it in the environment, if you're keeping it in the air, or if you're trying to keep it in the liquid. If it's in the air, frictional force; liquid, viscous force. If initial amplitude is xn, that is maximum, after time t, it will start decreasing with respect to this. X is equal to, what is this? This is basically x, or either x, xm, e raised to gamma times t, where what is this gamma? Gamma is your damping coefficient. Damping coefficient. Many books write gamma as b, so anyway it will stay still the damping coefficient. You might have written this as that. So what basically I want to say, that varies exponentially, so you have to keep that in mind. Damped oscillation is what, where the amplitude keeps on decreasing with respect to time as the time increases. Okay, now what of that is damped? What are forced oscillation? Oscillations in which body oscillates under the influence of an external periodic force, which is known as driver. That kind of oscillation is known as forced oscillation. Those oscillations which are being done under the influence of a particular force. The driven force, so driver is the particular force which is trying to change it. The driven body does not oscillate with a natural frequency, rather it oscillates with the frequency of the driver. Whatever frequency this driver, this particular external force will happen, with the same frequency, the particular source, what source will happen, like that only the receiver also will move. The amplitude of oscillator decrease due to damping force, but on account of energy gained from external source, it remains constant. So now what I did is damped oscillation started. Now damped oscillation decreasing means what? Amplitude will decrease over the time. So stop that, what I did, I forced that something from outside, so that whatever loss is happening because of viscous force or frictional force etc., that will be managed by forced oscillation. Okay, now resonance is what, when the frequency of the external force, that is driver, is equal to the natural frequency of the oscillator, that is driven, then the state of driver and driven is known as the state of resonance, and this frequency is known as what? Resonating frequency. The frequency at this condition is known as resonating frequency. Okay, this was, you would have heard that if some soldiers are marching and then on the bridge, if that matches, so the bridge might fall. But this all is true. It might happen when that is a case of resonance. Okay, so resonance is basically what? First condition, it should be a forced oscillation. In case of forced oscillation, what will happen? The watt frequency, the external force, which is driver, becomes equal to the natural frequency. Natural frequency means without any external force, you have just kept it in the air, and this normally how much frequency it is moving with. It will become equal to that natural frequency. When it becomes equal to that natural frequency, that thing is known as state of resonance, and the frequency, the state of resonance is known as what? Resonating frequency or resonant frequency. Okay, now in state of resonance, there occurs maximum transfer of energy from the driver to driven. That's why there's chances of breaking of things. You have heard about opera as well. So opera is also, because of opera you will see a glass is filled of water might break. It happens, again resonance is there in that. In state of resonance, the frequency of driver is known as resonant frequency. Okay, so now if I'm trying to define damping force, so see damping force is Fd minus Bv, where V is velocity and B is damping constant. Restoring force on the block is minus Kx. It is trying to go back again in this way direction. If you're trying to pull, the M is there in direction of this thing, so it is taking mg force downwards. It's trying to pull it, so it will put a F restoring force in opposite direction. Okay, so net force will be F net minus Kx minus Bv. Okay, minus Kx minus Bv. Kx is what? Restoring force of spring, and Bv is what? This is damping force. So both are in the opposite direction. They're trying to act in this direction. So net acceleration will be equal to this. This is what is the damped oscillation thing. You have to remember this. This is differential equation for, this is differential equation for damped oscillations. Differential equations for damped oscillation. Okay. Just still we are revising only. Okay, now this is what is the differential equation when we are talking about the differential equation which we did previously, and this is what is the solution for this differential equation. This is what is the solution for that differential equation for which one? Damping oscillation. Okay, now if I'm trying to find out energy in damped oscillation, that is what, this is what is the formula for that. E at t will be equal to E naught. E naught is the initial frequency. With that, like in the natural frequency condition, what was his energy? E raised to minus bt upon m. Okay, if it is not visible, I just write it over here. E at time t will be E naught exponential raised to minus bt upon m. Okay, where bt is what? Again, damping coefficient. Damping coefficient. Damping coefficient. Okay. Okay, next. So now for moving on to further, we have to discuss about the waves. So wave basically is what? It's a disturbance that propagates in the space. Basically anything, if you're throwing in the water, if you're trying to move a string in rotation, you're trying to revolve something, or someone is playing on some particular, like you'll have a lot of playing things which you try to, a lot of machines, a lot of we say, you know, when you go to fairs and all, you'll have a lot of machines of where you can enjoy movements of this thing going up and down, rotation, breakdowns and all. So classification of wave is done on medium of necessity. Medium of necessity means if you need someone to propagate, you need some medium for it moment. So based on that, it is classified as mechanical waves and non-mechanical waves. That is electromagnetic wave. Electromagnetic wave doesn't require any medium. Propagation of energy, progressive wave or stationary wave. It doesn't move. Progressive means it will progress because of the formation, like formation of ripples is example. So because of the vibrations of the particles, one vibration of one particle will pass to the vibration to the other particle, then other particle. Because of that, it will form a progressive wave situation. Vibration of medium particle, transverse and longitudinal wave, light wave and sound wave. Dimensions 1D, 2D and 3D. Okay, it's fine. So we have all the examples here. A mechanical wave will be transverse or longitudinal. depending on the nature of medium and mode of excitation. Okay, so this all is not that much important for you, but just all this all is part of your syllabus. So for studying parameter, I have included it. What is important is plane progressive waves. Equations for this very carefully. Wave equation is a sin omega t minus kx, where k is equal to 2 pi lambda. You know lambda is what? Wavelength. Wave constant, this is wave propagation constant, which is given by 2 pi upon lambda. Very, very important formula. In case of plane progressive wave, k, which is wave propagation constant, the formula is equal to 2 pi lambda. Differential equation is not important in case of plane progressive wave. You are supposed to know wave velocity, that is phase velocity, which is omega by k. Now k is again propagation constant. Okay, particles velocity, that is Vp, is dy upon dt. If you differentiate, well, obviously when you differentiate the displacement, it gives you velocity. So when you get this velocity, so now Vp is equal to minus v into slope. So minus v dy by dx. Okay, particles acceleration, again you differentiate the velocity, you'll get particles acceleration. Okay, now you can see that for particle one, whenever the Vp is decreasing, AP is also decreasing. Okay, particle Vp is increasing, AP is decreasing. So Vp is for the particle 2 at this position. So what is happening? Velocity is increasing because it is speed by time. Now what is that? So displacement time, but acceleration is decreasing because change in velocity is what? It will become negative. You'll find change in velocity with what? Final minus initial upon time. Final is less than the previous one, so you'll get a negative value. So based on this, we have particle 3, particle 4. So we write it in based on this. We talk about particle 3, again it is decreasing. After this, it will start increasing. After this, it was increasing. So that's why you're getting this situation in 1 and 2. This is just because it is on the negative side. Displacement, because we have to take displacement as negative positive, because displacement is what? It's a vector quantity. So based on the graph also, we'll do the same way. I have whichever is in the negative direction of x, I try to keep it in that way. Okay, so we have energy in wave now. So relation between phase difference, path difference, and time difference. Energy in a wave motion is kinetic energy per unit volume. Formula is this for again progressive wave. Potential energy per unit volume. Formula is this. Total energy per unit volume. Okay. Important factor is what? Pressure energy density is very important for you. Pressure energy density is what? It's average total energy upon volume. So if this is important. Power, that's not that much important. Still formula is included. Power is equal to 1 by 2. Then we have density here, rho omega square a square. S is the area of cross section. V is the velocity. Okay. Now this is important when you're talking about interference of waves, you say, or superposition of waves, you say. So if I have two constructive interference, I have two. Y1 is like this. So y and y2 is like this. I'm trying to add. So this is the phase difference here is kx. Here the phase difference is kx plus phi naught. So if I'm trying to add this, I'll get y as this. If I'm trying to find the resultant amplitude, I'll use this equation to find out the resultant amplitude, because both the displacements are vector. To find out resultant of two vector, we are using parallelogram law of addition here. So using parallelogram law of addition, we are trying to find out vector addition. This is parallelograms law of vector addition. So using this, we are trying to find out this tan phi a2 sin phi naught plus a1. From this we get to know that intensity is directly proportional to a square. We have used this also when we are trying to solve questions related to optics. We'll try to solve questions today for those chapters which we have already done in the physics, few questions if time permits. Okay. Now for constructive interference, phi naught, that is phase difference, is 2 pi n pi, which is also known as path difference, is equal to n lambda. Phi naught is equal to 2 n pi, or path difference will be equal to n lambda. This is when constructive interference, means both are overlapping exactly. So other wave is also coming exactly on this. So they're overlapping. So that time you get I maximum, most possible, like bright fringe we say, or most brightest light. So I max is this. When you have destructive interference, phi naught will be this, path difference will be this. Okay, I minimum will be given in this, negative of this. Degree of hearing is I max, I minimum into 100. This is degree of hearing is not that much important, but Maybe, may not be. If you are reading it, one formula is, I don't think that if you're reading that much, one formula makes much difference. Now, there is another condition, beats. Beats is what basically when two sound wave nearly, this is a condition for beats, that this is basically the topic is beats. This is only possible when we have waves of nearly equal, but not exactly equal. Conditions very clear. It should be nearly equal. It should not be completely or exactly equal. Frequencies travel in the same direction. They are supposed to have nearly equal frequencies traveling in the same direction. At a given point, due to their superposition, intensity alternatively increases or decreases periodically. Okay. But what happens? Their frequency is equal. They're moving in the same direction, but they're not exactly equal. Some difference will be there, like this. So some will be like this. Some small difference will be there. So because of that, whenever they'll be superimpositioning or they'll be superpositioning on each other, so they'll be alternatively increase and decrease intensity. So this periodic waxing and waning, when they're together, it is when they're increasing, that's waxing. When they're decreasing, that is waning, is known as beats. Okay, you need to remember beats as what? Beats basically you're supposed to remember only two conditions: sound waves of nearly equal frequencies, but they should not be equal. They should be traveling in the same direction. So what will happen, say if one have frequency of mu1, other will have frequency of mu2. So beat frequency will be, it can be mu1 minus mu2 or mu2 minus mu1, both. You have to just take modulus, positive value of that. So that's what is the thing, v2 minus v1 or v1 minus v2 under mod of this. So if you are taking, or you just see normal condition, what we say, bigger minus smaller. That is what is beat frequency. Okay. Next, what you are supposed to know is stationary waves or standing waves. When two waves of same frequencies, here where we are wording the use, same frequency and amplitude travel in opposite direction at same speed. Okay, conditions very clear. Stationary waves are what? Beats what happened? Nearly equal frequency. They travel in the same direction. So because of their superposition, they'll have intensively, alternatively increasing or decreasing, which is happening periodically. That is what is beat. Formula is nu1 minus nu2 under mod, or if you want to do just bigger minus smaller. Okay. But stationary wave or standing waves are what? They'll have what? Two same frequency, same amplitude, but they're traveling in opposite direction at the same speed. Okay, so their superposition will give rise to a new type of wave, which is known as stationary wave or standing wave. Okay, basically in terms of mechanical, you want to study. So I have F1, I have F2, where mass, acceleration, everything is same, but they're opposite of each other. Okay, so frequency is same, amplitude is same, but they're traveling in opposite direction with the same speed. Okay, so this will give you rise to a new stationary waves. So stationary waves condition is what? When two waves have same frequency, same amplitude, they're traveling in the opposite direction, okay, with the same speed again. So that's what will give you rise to the standing wave. So we have taken y1 is this, y2 will be this. Say one is negative, other one is positive. Okay, everything is same. Frequency is same, amplitude is same, speed is also same, only direction is opposite. Okay, so when you are adding them, you'll get this thing as equation for your stationary wave. Okay, so as this equation satisfies this thing, it represents a wave. This basically represents a wave. Its amplitude is not constant but varies periodically with the position. Okay, so what is that? They both have, now once they are superimposed, they'll have some new amplitude. So that amplitude will be what? It will not be constant, it will be varying periodically. Okay, it will be varying periodically. Now nodes is what? Where amplitude, those positions where amplitude is minimum is known as amplitude. In chemistry also, if you remember, nodes is what? That place where the finding out the electron probability is 0. Okay, or less. Antinode is amplitude is maximum. So this values where these are maximum, where cos kx will be equal to 0, or where cos kx will be equal to 1 for maximum, for minimum. Conditions in case of this is very important, so you have to keep that in mind. Intensity formula, speed of a transverse wave in the string, that's formula. This you don't have to remember the key points. Okay, now let's come back to this thing. Now nodes divide the medium into segments, or you say it as loop. Now see, you can see in this. Okay, first let's see this. All the particles in a segment vibrate in the same phase, but in opposite phase with the particles adjacent segment. Here they will be vibrating here. All of them will be vibrating in the same phase. But when I'm comparing with this one and this one, this will be vibrating in which phase? This will be vibrating opposite of that. Okay, as nodes are permanently at rest, so no energy can be transmitted across them. That means energy of one region is confined in that region. That means energy from this region cannot be transferred to this region. That's what is the second thing says. Okay, so now we have to talk about what? We have to talk about the transverse stationary waves in stretched string. Formulas of fundamental harmonic motion. So fixed end are node and free end are antinode. Free end are antinode, maximum amplitude, fixed end is our node, that means minimum amplitude. Minimum amplitude point are this, maximum amplitude here, minimum amplitude, maximum amplitude. So antinode, node, antinode, like that. Okay. So the fundamental of first harmonic is given as lambda by 2 is the length. Okay, this is length is lambda by 2. Fundamental of first harmonic formula is F is equal to V upon 2L, where V is velocity, F is frequency. Second harmonic, 2V by 2L. Third harmonic, so it is basically NV by 2L. Okay, NV by 2L. Basically, when I'm talking about string, how I'll write that? So it will be basically frequency. If I'm trying to find out, it will be NV by 2L. NV by 2L. Okay. This is for string. Now when it is fixed at one end, this is how it will change. Fundamental will be V by 4, one fixed one. There it was not fixed, both the ends were open. It was not trying to fix. Now it is fixed at one end, other end is read. You're supposed to, there it was fixed at the previous one which we read was fixed at both the end. Here it is fixed at one end. When it will be fixed at one both the ends, it will be upon 2L. When it will be fixed on only one end, that time will be upon 4L. Okay. So 3B by 4L, 5B by 4L, 7B by 4L. Okay, next is what you are supposed to read is sonometer. Formula is there. Fn is equal to P2L or T upon mu. Okay, P is number of loop, L is the length, T is the tension, mu is the material. Okay. Now we have what is, we have open end organ pipe. Okay, open end organ pipes. For this also the formulas are there. V by 2L, V by 2L, 3 by 12. Okay, how many loops I can see here is 2. So here again also 2. This total if you add 2, and this out is 3V. So this is what is the values for these things. You just see the formula so that we can solve the questions. Okay, these are few intensity of this few properties of characteristics of sound. You say what was there is, this is the talk about intensity is measures in decibel. This is how I naught is a threshold of human ear. Threshold means minimum energy which it is supposed to, or minimum sound it is supposed to hear. Like that much sound only it can hear, lesser than it can't. So there are few properties, characteristics of sound, which there are few properties which defines the characteristics of sound. One is loudness, that is sensation received by the ear due to intensity of sound. It depends on the intensity, or intensity you can say directly depends on amplitude. Pitches, sensation received by the ear due to frequency of sound, so directly proportional to frequency. Quality or timbre, that is sensation received by the ear due to the wave form of the sound. Okay, so basically quality is, and talking about loudness, to differentiate between what, if I have to differentiate between a male and female voice, we try to use pitch. Which when we talk about something was a girl's voice, they'll have high pitch because they'll be more shrill. For boys, it will be normally not that much shrill. Okay. Now we have to read about Doppler's effect. Doppler effect formula is important, nothing else. So formula will be basically written in this format. N dash, that is observed frequency, will be equal to speed of sound waves with respect to the observer upon observed wavelength. So this is what is the formula. I'll write the formula here. N dash is equal to V plus V naught upon V minus PS. It can change according to plus and minus. Also, it can happen. It's not like it will be always plus, or depends on what it is. If I am having like you can write it in this session that it's plus or minus. If I'm trying to write, if it depends on what is, if it will be if it on the top it will be plus V naught, depends on what it will be plus V naught when it is moving towards the source, and it will be minus V naught if it is moving away from the source. Okay, this will be what when it is moving towards, so it is moving towards the source, and if this is moving away from the source, okay, V naught, and it will be plus Vs and minus Vs again also have condition. This will be ulta of that. Okay, it will be plus Vs, it will be only it will be plus Vs in case of which if the source is moving away. If the source is moving away, the source is trying to move away from this, source is moving away, and this will what the source is moving towards. So we'll see in the terms of questions how this and all will be solved. Okay. At meanwhile, whatever the formulas are there and whatever physics, whatever we have read, we'll try to get into that. We'll try to solve few questions related to them. Okay. Fine. We'll start solving few questions from the terms of dimensions itself, so that whatever physics I have to try to see, we'll see whatever physics is there, we can at least try to solve those questions. Okay. So another questions are what? First question based on, we'll start off with the dimension and then we'll go to the further things, thermodynamics and then material properties, mechanics. Okay. First question is, we have an equation given as force is equal to AT plus BT square, where your T is equal to time, where T is equal to time. Okay, so you have to find a dimension of A and B. To find dimension of A and B, right? Okay, we have only 2 students who will be trying it. Very good. All of them have studied everything. Okay, find A and B. Okay, so if I'm trying to find the dimension for this things according to principle of homogeneity, I have answer MLT minus 3. So Jain have given it as MLT minus 3 for A. Okay, so F is equal to AT and also F will be equal to BT square. So as I know that this will be F is equal to MLT minus 2. MLT minus 2 upon T is equal to MLT minus 3. Good. Okay. So Jain have answers MLT minus 3, MLT minus 4. Okay. MLT minus 3. For this, it will be again MLT minus 2 upon T square. So MLT minus 4. Good. Okay. Next question. What will be the dimension of specific heat? Dimension of specific heat. Okay, so dimension of specific heat, if I'm trying to form the formula, it will be Q by MT. Q by MT. So if I'm trying to find the Q is nothing but work done. So ml square minus T minus 2 upon M. This is temperature. So this temperature will be in Kelvin. So I'll get the formula as L square T minus 2 Kelvin minus 1. Okay. Let's try another one. Okay. What will be the dimension for coefficient of viscosity? Coefficient of viscosity. High coefficient of viscosity. Okay, coefficient of viscosity, if all of you remember Stokes' law. So according to Stokes' law, we write what? Viscous force Fv is equal to 6 pi eta Rp, where eta is your coefficient of viscosity. So eta will be basically equal to F upon 6 pi Rv. For constants, we don't have any units. So F is equal to what? MLT minus 1 upon R will be basically L. Okay, and V is equal to LT minus 1. If I do this, 1L, 1 will cancel this. Okay, so this is T. Okay, MLT force will be MLT minus 2. So T minus 1 goes upon, so it will be ML minus 1, T minus 1. ML minus 1, T minus 1. Okay, fine, good to go. Next, try to find out the gravitational constant Z, gravitational, universal gravitational constant. Dimension for universal gravitational constant, capital G. Ritik Madhav have answer as m minus 1 L cube q minus 2. So basically I have what? Force is equal to, okay, both have same answer. Contradicting answers, then I'll try to check. Same answers, then I don't try to check. Right. Let's go to the wave score questions, which we have done today. Okay. Okay, so the first question for this is, okay, standing waves are produced in 10-meter long stretched wire. You have a wire, which is, so we are producing what? Standing wave. I could not get the question over here. Just write it down. So we have a standing wave of a wire, okay, which have a length. So wire's length is how much? Length of the wire is equal to 10 meters. Okay, if the string vibrates in 5 segments, okay, 5, so total number of segments of vibration, segments of total is 5, okay, and the wave velocity is 20 meter per second. Wave velocity is 20 meter per second. 20 meter per second, then what will be the frequency? You need to find out frequency. What will be its frequency? So frequency will be equal to what? Options are A 5 hertz, B 2, C 10, D again 2. I don't know why 2 options, but both the options are 2. Yeah. The answer is 5. The answer is 5. Answer I think is right. Okay, I'll just give the basic idea of this. The question will be like, say they are telling it is 5 loops. So 1, 2, 3, 4. Okay, so I have 1 loop, 2 loop, 3 loop, 4 loop, and 5th loop. So I have 5 loops. So from 5 loops, okay, I have 5 loops. For the 5 loops, so 1, 2, 3, 4, 5. This idea of this. So basically, what is wavelength is? So for this wavelength is basically what? From here to here. That is what we take it as wavelength. Okay, this is wavelength. So we have total 5 loops, but I have 5 loops for 10 meters. That means for 2 loop, it will be how much? For 1 loop, it is basically 2. So for 2, it will be equal to 4 meter. So basically what I got, lambda is equal to 4 meter. When I got lambda is equal to 4 meter, I know the formula velocity is equal to nu lambda, that is frequency. So nu I have to find out, nu is equal to velocity upon lambda. Velocity is 20 meter per second. This is 4, which gives me as 5. So answer is right. Ritik's answer is right. Okay, see, I'm giving you only the concepts for those people who have not solved. Okay, or if you're having some difficulty to apply, just take all these classes as a revision session. So you're solving the questions. If you're understanding good, if you're not, you can ask the doubt. If you have forget and you have some concept, which these questions will help you to revise that as well. Okay, I'll go to the next question. So the next question is, at which temperature Next question is, at which temperature velocity of sound at 27 degrees Celsius doubles? Okay, at which temperature velocity of sound will be, it will double? Options are: A is 327 degrees Celsius, B is 927 degrees Celsius, C is 54 degrees Celsius, and D is minus 123 degrees Celsius. At which temperature velocity of sound at 27 degrees Celsius doubles? This is exactly what is the question. This was small, so I wrote all of them. Ritik says 927. Ritik says 927. Anyone else? So question basically is what? Velocity of sound is, say, directly proportional to root over temperature. Very important, temperature is basically on this absolute scale, so you are supposed to take it in the Kelvin, not in degrees C, first thing. So now V1 upon V2 will be equal to root over T1 upon T2. So this will be equal to basically 2V upon V will be equal to T plus 273 upon 27 plus 273. But basically you get it as what? 2. You just square it so that the roots will go over. So it will become 2. We will get cancelled. So 4. So T plus 273, and this becomes what? 300. So basically what it becomes, 1200 minus 273. So it's basically 927. Yeah, that's it. Right. Next question. Let's go for the next question. Okay. So the next question is, there is a wave equation in the form y is equal to 0.30 sine 314t minus 1.57x minus 1.57x. Okay, where t, x, and y are in second, meter, and centimeter respectively. You're supposed to find the speed of wave. Speed of wave is what? Options are, speed of wave is what? Options are 1250 hertz, 1250 hertz. B is 1050 hertz. C is 700 hertz. D is 1400 hertz. How can be speed in hertz, right? So options are wrong. How can be speed in hertz? Frequency can be in hertz. Okay, so options will be 400 meter, 400 meter per second. Option B is 100 meter per second. Option C is 200 meter per second. Option D is 50 meter per second. Sujan also have answered. Sujan have also given the same answer. This question is easy. I think so. If you compare with the standard equation, that is standard equation is y is equal to a sine omega t minus of kx. So from here you can write that omega is equal to 314 and k is equal to 1.57. So I know that b is equal to omega upon k. So omega is 314, 1.57. So 100 goes off 2 times, so 200 meter per second. Okay. So good. So John also gave answer this time. Just take a blank slide. Go to the next question. Next question is, okay, an object is producing a pitch of 1200 hertz, and it's moving with a velocity of 50 meter per second, towards a stationary person. Okay, it's moving with a pitch is this much, and this much is the velocity of sound. Velocity of sound is equals to 350 meters per second. 350 meters per second. Okay, so the question, the frequency of sound, heard by the stationary person. The stationary person is, Ritik, I have yet to write the options. Okay, I just finished the question. The frequency of sound heard by the stationary person is, okay, A is 1250 hertz, B is 1050 hertz, C 700 hertz, D 1400 hertz. So Ritik have already answered as 1400 hertz. Others can try. Doppler's effect question. Okay. Okay, if I'm trying to write it using the formula for apparent frequency, so apparent frequency is N into Vs minus V naught, where N is what? The frequency which is given here. I have to find out the apparent frequency. The pitch is 1200 hertz. Okay, that is what is your frequency. Vs is velocity of source, and then it's a velocity of sound, and V is velocity of observer. So it is 1200 times Vs is how much? 350 upon Vss 350 minus of 50. This will give you answer as 304. 814. Okay, let's go to the next question. The next question is, okay. So the question is, the next question is the air column in a pipe which is closed at one end. So there's an air column which is closed at one end, closed at one end. Okay, will be in resonance with the vibrating tuning fork. Okay, closed at one end. What is closed? An air column pipe closed at one end will be in resonance with with the vibrating tuning fork at a frequency it's at a frequency 260 hertz. It's a frequency 260 hertz. The length of air column will be, though you have to find out the length of the air column is. The length of air column is option A 12.5 centimeter, option B 35.75 centimeter, option C 31.92 centimeter, option D 62.5 centimeter. Ritik have answers 31.92. Ritik, you got answer exactly as 31.92.
$31.5.
Getting answers 31.5. Okay. So see, for fundamental frequency, the formula is V upon lambda, and it is also it's equal to lambda upon 4. Okay. So from here I can write what is the length is equal to, or I can write as lambda is equal to 4L. Right. So indirectly, if I want to write the formula here, I can write that N is equal to V upon 4L. I gave you the formula. When it is closed from the both end, it will be upon 2L. When it is closed from one end, it is VL. So N is given to you, that is 260. The frequency is 260. 260 is equal to 330 velocity of sound. 330, 260 times, sorry, so 4L, no? So 4 into, I need to find out length. So now I can find out L is equal to 330 upon 4 into 260, which is this. So 4 times 8 is 32, 8 point basically 25. So 26, right? L 26. So it basically will be something around 0.317. So you are basically getting this much meter. So it's basically 31.73 centimeter. Nearer to this answer is 31.92. Okay. So 31.92 is the answer. Okay, anyone doubt? Okay, so the next question is, you have a transverse wave in a string with an equation of y is equal to 10 sine pi 0.02 x minus 2.00 t, where x is equal to, x is in meter, and t is in second. X is in meter, t is in second. You have to find what is the maximum velocity of the particle in wave motion. You have to find out V max. Maximum velocity you have to find out. Options are 100 meter per second. Ritik have answered already. B is 63 meter per second. C is 120 meter per second. D is 161 meter per second. So his answer is 63. Okay, you don't have to do anything, you just differentiate this with respect to time. So dy by dt. Dy by dt will give you velocity. Okay, velocity, and that will give you dy by dt. So dy by dt, you differentiate it, you will get it as 10 cos pi 10 cos pi 0.02x minus 2t into pi into, so you'll use this, so you'll get answer as 63 meter per second. Okay. See next questions. The next question is the tension. Okay, so the next question is the tension in piano wire. Tension in piano wire is 10 Newton. Okay, the tension in piano wire to produce a node of double frequency. Need to find out what? Find tension in this piano wire to produce a node of double frequency. The correct answer is 40. Options are 20 Newton, B 40 Newton, C 10 Newton, D 120 Newton. Okay. So just the relation is frequency is proportional to under root the tension. So because to make it double, I need to make it 4 times. So the answer for this will be 4 times 10, that is 40. Frequency is proportional to under root of t. Okay. Next question is two sound wave have phase difference of 60 degree. Then they will have path difference of options A is equal to 3 lambda, B is equal to lambda by 3, C is equal to lambda upon 6. D is equal to lambda. Okay. The formula for path difference is basically path difference is equal to lambda upon 2 pi of phase difference. That's formula. So if I am phase difference is 60, so lambda upon 2 pi is equal to pi by 3. 60 degree, I can write pi by 3. So this basically gives you what? Lambda upon 6. Okay. So we'll try to solve few questions depending on mechanics part that we have already previously studied. Okay. So the question is, if S is stress, if F is stress and Y is Young's modulus, if S is stress and Y is Young modulus, then energy stored in the wire per unit volume, will be equal to how much? The options are A is equal to 2s square y, B is C is equal to need to find out what is. Okay. Option is D. Okay. We'll see. Let others also solve. Okay, so the formula for stored energy stored per unit volume, energy stored per unit volume will be equal to half stress into strain. So I have already stress is what? Stress is basically S. Strain, we're using Young's modulus formula is what? Stress upon strain. Young's modulus is basically stress upon strain. Like in that, strain is equal to stress upon gamma. So stress is again one more than gamma. So the answer will be S square 2y. Okay. Fine. Next question is, if in a wire Young's modulus is y. If in a wire Young's modulus is y, longitudinal strain is x. Longitudinal strain is x. Is produced. Then the potential energy stored in its unit volume will be first 0.5x square y, b 0.5 y square x, c 2yx square, d yx square. Okay, so using the same formula, I can write it as what half stress and strain, half stress and strain. If I use this, I'll get basically half into y, half into y into x into x. So I'll get the formula as 0.5 x square into y. Okay. So what is the thing? Next questions. Okay. Next, we'll go to the next question. The next question says as the bulk modulus the bulk modulus of a metal is equal to 10 raised to 10 Newton per meter square, and Poisson's ratio is equal to 0.2. Average point if average distance between the molecules, if the average distance between the molecules is 3 angstrom, then the interatomic force constant will be equal to options 5.4 Newton per meter, B 7.5 Newton per meter, C 7.5 Newton meter, and D is 30 Newton meter. Okay, see with this question. what they have given you bulk, the relation which interrelates this is Young modulus is 3 times bulk modulus 1 minus 2 times of Poisson's ratio. So Young's modulus I can calculate using 3 into this is 10 raised to 10 meters, 1 minus 0.2 into 0.2. So this will be basically 3 into 10 raised to 6, 1 minus 2 is a 0.4, 3 into 6, so 3 into 0.6. So basically it will be how much? 3618. So 1.8 into 10 raised to 10. This will be Newton per meter square. Then interatomic force constant formula. Interatomic force constant formula is equal to Young's modulus time distance between the two molecules. So gamma I calculated 1.8 into 10 raised to 10. This is 3 Armstrong. So 10 raised to minus 10 meter. This cuts this. So which is equal to 5.4. 5.4 Newton meter. Option is A. Ritik have answer right. I've given answer as 5.4. Next question. There are two wires, wire 1 and wire 2. So they have same material, same length, diameter. What is there is diameter of the second wire. So diameter of second is equal to 2 times diameter of first. 2 times diameter of first. Okay. We need to find out the ratio of extension, produced, in the wires by applying same load will be. So you have options are 1:1, B 2:1, C 1:2, D 4:1. Okay, we'll try to solve. Now, what is given here is both the wires have same materials. So if they have same materials, that means their Young's modulus will be same. So if I'm trying to find out their Young's modulus, the Young's modulus will be basically if I'm representing them by y. So what they have given is that y1 is equal to y2. So if I'm writing the formula for this, so force into L is equal to A1 because length is same, A into delta L1 will be equal to F into L into A2 delta L2. This gets cancelled from your FL and FL. So basically what I get is, if I'm just trying to convert the area, so because that is pi r square, and pi also get cancelled, so I'll get it what? R1 square into delta L1, that is extension, is equal to R2 square delta L2. So which basically gives us what is, if I need to find out the ratio of extension produced in the wires, so I'll try to find out R2 by R1 square. So R2 upon R1 square is equal to delta L1 upon delta L2. Normally, if they don't mention which to which, we try to say, take always try to find the ratio of L1 and L2, like 1 upon 2 if they have not mentioned anything. So delta L1 by R2 by R1 square. So they have given you diameter basically. So I can write that if diameter. Okay, I'll write it here. So what basically I have is R2 R1 whole square is equal to delta L1 upon delta L2. So now diameter is there. So anyway, in diameter also, if you write 2 will get cancelled. So basically, you'll get it as what? 2 square, 2 by 1 whole square, which is equal to 4. So your ratio basically you're getting it as 4:1. Yeah, okay. B is the right answer. B is the right answer. Okay. Go to the next question. So the next question says is there is an iron rod. An iron rod is there. Iron rod whose length is 2 mm or 2 meters, sorry. Cross sectional area is 50. Cross sectional area is 50 millimeters square. Is stretched by, so delta L is equal to 0.5 mm on load of 250 kilograms. Okay. You need to find out y is equal to what? Young's modulus is what? Options are 19.6 into 10 raised to 20 Newton per meter square. Number B is 19.6 into 10 raised to 18 Newton per meter square. Then answer the option 3 is 19.6 into 10 raised to 10 Newton per meter square. D option is 19.6 into 10 raised to 15 Newton per meter square. Okay. how much time is allotted in exam, sir? For 30 questions for each segment, 30 questions, 60 minutes. Okay. We'll see the solution. As we know that Young's modulus is equal to stress by strain. Stress is given by force upon area. Strain is given by a change in dimension by original dimension. So delta L upon L. Now force is 250 kg converted to 50. We're trying to convert it into grams. So I can try to. I'll just try to do W into G. So W into G will be what? So let's. We will take G because nothing is mentioned in the question. So G we should take, if nothing is mentioned, we'll try to take it as 9.8 upon the area. So area will be 50 millimeter square. So 10 raised to minus 6 upon, I have this delta L, so 0.5 times 10 raised to minus 3 upon L, that is 2 meter. So this will be basically how much? 250 into 9.8 upon 50 into 10 raised to minus 6 times 2 upon 0.5 raised to 10 raised to minus 3. So 50 times 5, this one, and then I have 10 raised to minus 10 raised to minus 9, this one. 598 40.5 to will be 19.6 10 raised to positive 10, right? To positive 10. So 10 Newton into 10 raised to 10 for this one. Okay.
Sir, why we always take a cross-sectional area?
Because that's the, when I'm talking about the, if they have not mentioned it, that means I have to take about the area which is on applied. On normal rod, when I'm talking about the Young's modulus, if they're telling me to find out Young's modulus, this has to be normal stress by normal strain or longitudinal stress by longitudinal strain. So in that case, the force always acts on this, unless and until they're not mentioning. If they're mentioning it also, if they're changing the cross-sectional area, they can either put on this. So in that sense, I'll take this area. But for iron rod and all, normal force is applied on these things. For Young's modulus, it has to be normal stress or it has to be the longitudinal stress. Okay, we'll try to solve few questions related to thermodynamics. Okay, so thermodynamics, first say the first question is the latent heat of vaporization. The latent heat of vaporization is of water is 2240 joules. Work done in the process of vaporization. Work done in the process of vaporization of 1 gram is 168 joule. Then increase in internal energy. Then increase in internal energy is, options are 1940 joules, B 2072 joules, C 224 joules, then 2408 joules. Okay, so we'll try to solve this question. What is there in this question is, if I'm talking about first law of thermodynamics, Q is equal to change in internal energy plus change in work. So here basically what is given, that Q is given to your latent heat of vaporization is 2240 joules. And if I'm talking about the work done is equal to 168 joules. So if I substitute it here, I'll basically get the change in internal energy is equal to 2240 minus 168. So the answer will be 2072 joules. 2072 joules. Okay. Next question. The internal energy change, that is delta internal energy in a system, delta internal energy system that has absorbed 2 kilocalories of heat, 2 kilocalories of heat, and done 500, or it gives 500 joule of, or it have done 500 joule of work is number A 6400 joule, number B 5400 joule, number C 7900 joule, number D is 8900 joule. Answer of it is 8900.
What is difference between electrical conductivity and thermal conductivity?
Electrical conductivity is really how something is reacting to electricity. Thermal conductivity is how good something is reacting to heat. All the bodies which are good conductor of electricity doesn't mean they're good conductor of heat as well. Something which is conducting good heat is having good thermal conductivity. Thermal is related to heat. Electrical conductivity is related to electrical. If you're passing this much amount of charge, if you're passing this much amount of current, how it is that body is reacting. That is, it's basically electrical conductivity. And if you're passing this much amount of heat, that is Q. So both is different. One is Q, that is charge. Another Q is heat. So one place you are trying to calculate for this much amount of electric current or for this much amount of electric charge, how that body is going to behave. And when thermal conductivity for this much amount of heat, how that body is going to behave. So that is what is the difference between electrical conductivity and thermal conductivity. Okay, so now again, this is using first law of thermodynamics. Q is equal to delta U plus delta W. We have to find internal energy, that is Q minus W. So Q is basically, they have given you 2. Okay, so I can calculate it using 2.4.2 to convert it into joule into 1000 minus W, that is 500 joule work. If I'll solve this, it will be how much? 248.4, so 8400 minus 500. I am getting answer of 7900 joules. Thick.
Yes, sir. My mistake.
Okay. Next question. Next question is the average kinetic energy. The average kinetic energy of gas molecule at 27 degrees Celsius is equal to 6.21 into 10 raised to minus 21 joule. So what will be its average? You need to find out kinetic average at 227 degrees Celsius. 227 degrees Celsius. A option is 10.35 into 10 raised to minus 21 joule. B is 11.35 into 10 raised to minus 21 joule. C is 52.2 into 10 raised to minus 21 joule. D is 5.22 into 10 raised to minus 21 joule. Answer of Ritik is A. Anyway, I'll just give you the formula. Formula for this is what? Formula this is given as average kinetic energy of gaseous molecule. Average kinetic energy of gaseous molecule is proportional to temperature. That is absolute temperature. That is, you are supposed to take it in the Kelvin. So if I'm doing is what will be there? Kinetic energy at 227 degrees Celsius. I'll take kinetic at 227 degrees Celsius upon kinetic energy at 27 degrees Celsius. So if I'm taking it, it will be 273 plus 227 upon 273 plus 27. So I'm getting the ratio as 5/3. So 5/3, the value is 6.8, 6.21 at 27 degrees Celsius. So 5/3, I can write that kinetic energy at 227 degrees Celsius is equal to 5 times 3 into 6.21 times 10 raised to minus 21 joules. So 6, okay, so around this. Okay, so this will be the right answer. So this is mixture of questions. We are still left out with few such sessions of your physics. Chemistry is done. Maybe if you have getting revision things, we are again doing more questions. In case of physics, we are left out with electromagnetism still. So we'll continue our classes next. For time being, we are done for today's class. Thank you, everyone. Good night.
Good night, sir.